So question number 1 gives us the point G, 3 comma negative 5, and it's going to be reflected over the line y equals negative 2. And we want to know what the image of G prime is. Okay, question number 2. Also we're reflecting, but we're reflecting over the line y equals negative x. Okay, so if we were to create a t-chart with my x and y value, if I made x 1, that means y is the negative of that, so it's going to be negative 1. If I had negative 4, a negative 4 would be a positive 4. So what we have is actually a graph that goes through the origin at a diagonal. So we're reflecting D, E, and F. Okay, so when we are, this line's a little different in terms of reflection because it's diagonal, not straight up and down or across. But we're still going to count, and it's still going to be equidistant. So the difference here is that we count twice instead of, so if I had a vertical line, I would count the number of units to the line and then the same number of units over. We are only going in one direction. But because of the diagonal, I'm going to go up, and then to go over the line, I need to go to the right. So let's take example of point F here, okay? The other thing you need to take a note of is that the coordinate plane is by 2's, okay? So when you plot your point, just make sure you're not counting each line as a single unit. Okay, so from F, I'm going to count 1, or I should say each line is 2. So this is going to be 2, 4, and we can assume this is 1 because I'm in between 0 and 2. So this is actually 5 units. And then I'm going to count 5 units over the line. In this case, it means I'm going to go to the right 5. So because I am at negative 1 on the x value, I can assume my 1 unit to the y. So that's 1, and then 3, and then 5. So that puts me at f prime at positive 4, 1. Now, if counting on this graph is too confusing, there's no reason why you can't use the other graph paper. So let's say, so f is at negative 1, negative. Take a look at the other points. So let's say, so D is negative 8, negative 5. Okay. Now, you'll notice this is a multiple choice question. So if you notice, I just determined that D prime was 5, 8, and that happens to be the only choice that has 5, 8 for D prime. So I only needed to count one, I only needed to reflect one coordinate. But as you can see, we also did f prime. So for the test, I would recommend using our own graph paper rather than the one that's on the test, because counting by 2's could be, because as you notice, when I did it, I was off by 1, so it could pose a problem. So just something to keep in mind. Okay. Oops. So using our graph paper, I'm going to first graph 3, negative 5. So that's right 3, down 5. So this is G. Okay. And we're reflecting over y equals negative 2. All right. Now remember, y equals negative 2 means that no matter what the x value is, the y value will be 2. Or in this case, I'm sorry, negative 2. So I can go anywhere on the x-axis, but my y value will be negative 2. So 7, negative 2, 9, negative 2, negative 2, negative 2, negative 4, negative 2. And you'll notice this is a horizontal line that goes through the y-axis. So with our reflection, we just count the number of units to my line of reflection, and that happens to be 3. And then I'm going to count 3 units over. So G prime is at 3, positive 1. And that's all there is for question number 1. It's that simple. The key is remembering that y equals is a horizontal line. If you were given x equals negative 2, that would mean every x value is negative 2, and it wouldn't matter where on the y-axis you were. So x equals negative 2 means every x value is negative 2, and then my y value could be anything. So that is a vertical line. Just make sure you know the difference between the two of those. So negative 1, negative 1, 2, 3. Okay. So this is F. And remember, y equals negative x is this diagonal here. Okay, so on this graph paper, it's easier to see and it's easier to count because every line is 1 unit. So this is 1, 2, 3, 4. And as you can tell, I made a mistake when I counted on the other graph paper too. So even I found that confusing. So I went up 4. 1, 2, 3, 4. And then, so I'm going to go, again, we need to get over the line. So since my point is left of my diagonal line, I'm going to count right 4. 1, 2, 3, 4. And so F prime is at positive 3, positive 1. Okay, so negative 8, negative 5. This is a D. And you'll notice we're going up quite a bit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, that's 13. Okay. So again, count it up. Now I have to count right. 13. From 8 to 0. So that's 8, and I need 5 more. 1, 2, 3, 4, 5. So D prime is going to be at 5, 8. 5, 8. Did get 3, 1. It incorrectly. Over y equals x. Oh, sorry. Let's see, question negative 3. Okay, and we said that my line was at x equals 5. So 1, 2, 3, 1, 2, 3. Okay, so that would be D. So it is, except I plotted it at negative 4. So sorry, we're technically up 1 because I went down one too many. But yeah, so D should be at positive 8, negative 3. A diagonal line with a negative slope, what I'm going to have is a diagonal line with a positive slope. Okay. So negative 7 to the left, up 1. Okay. So this is F prime. Okay. So we're just going to reflect F prime over our line y equals x to find out what my original image was. So here, to get over my line, I need to count to the line, and then I have to count down, okay, to get over my line. So here I'm at negative 7 to positive 1. That's 8 units. So then I'm going to count 8 units down. And I almost made it. So this brings me to positive 1, negative 8. If, let's say, this is just another example, if I had a point here and I needed to get over the line, I would count up and then to the left. Okay, so the trick with reflecting over the diagonal is you have to count up and right or down and left. And that is 3. Okay. Another reflection. We have Jared has installed beehives at point A, B, and C. He wants to install a beehive at point D. That is the reflection of point B across the path. Okay, well, the path is my vertical line here. And what we need to notice, okay, so this is at 2, this is at 4, this is at 6. So my line is actually at x equals positive 5. So reflection equidistant. So this is at 2, this is 4, so this would makes 5. So that's 2, that's 3 units. Because from 2 to 5 is 3 units. So I'm going to count from 5, 3 units. 1, so 1 takes me to 6, and then 2 more takes me to 8. And that is also 3 units. And you'll notice we are at, so that's 2, this is negative 3. So we should be at positive 8, negative 3. But let's graph this on the other single graph paper just to be sure. So B is at 2 because we're supposed to be at, so this is 2, at negative 3, and I accidentally, there we go, yep. So yeah, so D would be at 8, negative 3. Okay. This should be our last reflection question. And you'll notice here it says when point F, which it doesn't give us point F, is reflected over the line y equals x, the image is F prime, negative 7, 1. Okay, so similar to our other question, if I create the t-chart x, y, if y equals x, then whatever my x value is, that's what my y value is going to be. So these would be my coordinates. Okay, they're exactly the same. So instead of, and F prime is at negative 7, 1. So positive 1, negative 8 would be my reflection. Should be all the problems that involve reflections.